This conference will now be recorded.
Lakshmi, you wanted to understand how to import a file into Databricks from your local machine, right?
No,
Is
no,
that
no.
your question?
Not how to import.
Mhm.
Like how to
Mhm.
retrieve already imported files instead of importing every time. Can I use the same file which is already there in the cluster?
Okay, the data you're talking about,
Mm-hmm.
correct? That is that
Yeah,
your
yeah.
question?
Yes, we have that file. I mean, file location, right? The link which we
Correct. Yes.
copy
So,
and then we
so
we.
exactly. So look here on the left hand side, you can click on data and click on create table. You can see DBFS here, right? DBFS tab. So click on file store tables, and most likely this must be the data. I mean, whatever is the data that you have already uploaded, you should be able to get the same here, right? So let's say this is the one that I have uploaded. If you can click on that file name, you can get the path here. You can copy paste that.
Oh, okay. Yeah, this is what I wanted to. Thank you so
This is what
much.
you're looking for, right?
Yeah,
Cool.
yeah,
Yeah.
yeah. Okay, thank you.
Okay. So now we have seen how to practice Spark on Spark Shell, and we have seen how to practice Spark online by using Databricks. And today I will show you how to practice Spark on Jupyter Notebook on your local machine. Okay, before doing that, you have to install a module or a package called as Find Spark. So on your local machine, open Anaconda prompt, and here you have to install something by saying Python space hyphen m pip install Find Spark. So this is what is required to practice Spark on local machine on Jupyter Notebook. So let me copy paste this. In my case, I already have it installed, hence you are seeing requirement already satisfied. But in your case, it should be installing the Find Spark package for you. So this is the command that I've pasted in the chat box. You can have a look. And once you do this, you can actually launch your Jupyter Notebook. So search for Jupyter Notebook and launch it. So, and then we are going to talk about Spark SQL today. I already have a notebook. I'm going to import the same. So I'll go to my downloads folder, and here I will search for Spark SQL. I'm using an existing notebook, by the way. Spark SQL, and then I'll pick up one of the files. Let's say I'll pick up this one. This is from previous batches, but again, not a problem. So this will be the same. So I have just selected that, and I can rename it also. Let's say December 2022. Click on rename. That's it. So once you install Find Spark, remember that you will not have Spark session available by default on Jupyter Notebook also. So there are some steps that you have to do to set up Spark session. You can see that first I'm trying to import Find Spark, and then I'm saying find spark.init. Init is nothing but initialization. And then I'm trying to import Spark session, and then I'm trying to create the Spark session by saying spark session.builder.get or create. So on Spark Shell, you will have Spark session available by default. On Databricks, you will have Spark session available by default. But on Jupyter Notebook, you will not have Spark session available by default. Hence, you have to create it. How do you create it? By following this approach. Then I'm verifying whether we have the Spark session created or not by saying type of Spark. Yes, it is creating Spark session for me. So that's how it's you have to make sure that you are basically creating the Spark session object, because you will not have it available by default on Jupyter Notebook. And then once you have the Spark session object available, then we are good to create our data frames. So I'm going to create my orders data frame by using orders JSON data. Let me go there. So I'm on my local machine. So I have my JSON data available. So here I have my orders JSON data, right? So this is where I wanted to basically show the data once. I'm trying to open the file by using Notepad++, and this is the JSON data. You can see order ID, order date, order customer ID, and then order status. So I'm going to create this data frame by using this JSON data by using Spark session.read format, load, and then give the full path. So this should create the data frame for me, right? And then once you have this orders data frame created, I wanted to create one more data frame by using customers data. So here in the same folder, I have my customers data also. I'm going to create my customers data frame by using this customers data. But first, let's have a look at the data. You can see that we have customer ID, customer first name, customer last name, customer email, customer password, customer street, customer city, customer state, customer zip code. All these fields are available. So we are trying to create the customers data frame by using Spark session.read.format is JSON and load and then customers data. So this has created the customers data frame for me. So one assignment here, the assignment here is you basically have to create a method or a function called as createDF, and that function should take the input as the path of the data and the file format. File format can be CSV or JSON or any other file format, and the output from that method should be a data frame that created one, right? The data frame that has been created. So see if you can solve this problem. Okay. So and as I told, we are talking about Spark SQL today, and the first step of Spark SQL is creating a data frame. So we are done with step one where we have created the Spark session. So we have created the Spark data frame. The second step is registering the data frame. How to register that? By using data frame name dot create or replace temp view and then any name. So let's say this is orders data frame, hence I'm registering that data frame with the name called as orders. And then the customers data frame, I'm registering it by saying create or replace temp view customers. That is, going forward, I'm going to refer to orders data frame as orders and customers data frame as customers. So let me run these two cells. So these steps are important because in the interviews, some of the interviews will ask, okay, what are the sequence of steps that are involved to work with Spark SQL? First step is creating a data frame. Second step is registering the data frame by using create or replace temp view. Third step is performing the actual operations. To do the actual operations, suppose let's say I want to project the data. Projecting the data is nothing but selecting all the fields that are required. Then I can say Spark session dot SQL, and then in the double quotes you can mention any valid SQL query, right? So what is this going to return me? It is going to return me a data frame. You can see that I'm printing the same type of Spark.SQL select star from orders. This is going to return me a data frame. And once you have the data frame available, how can you see the data in a data frame? By using show method or show action, right? So this is going to get me all the records on, not all the records, all the columns from this orders table, and because we are using show, this will give me top 20 records. And select star will give me all the columns. Suppose I wanted to see only specific columns. Let's say I wanted to see customer ID column and customer first name column from customers, then you have to mention those specific columns here. So let's try running this. You can see that we are getting only those two, customer ID and customer first name, not all the columns. So you can see that it's pretty much very simple, right? You just have to write some SQL queries. That's it. All you are trying to do is create a data frame, register it, start writing your SQL queries. That's it. That's why Spark SQL is very, very easy compared with Spark Data Frame APIs. But in the interviews and in the projects, Mostly we'll be going with data frame approach, whatever we have learned till yesterday. But knowing Spark SQL also is also important sometimes, because some situations where we wanted to implement the features faster, then we will go with Spark SQL. Okay, now let's talk about filtering the data. So how to filter the data in SQL? You can just use where class, right? If you look at the orders data here, we have orders with closed, pending payment, complete, and all that, right? Suppose I wanted to filter out my data, I wanted to get only the complete orders, then I can use where class, right? So let's run this query, spark session.sql, and then in the double quotes I'm mentioning my query. You can see that it is getting me only the complete orders now, right? But suppose let's say I don't want only the complete orders, I want both complete and closed orders. Then slightly modify your where class to include complete and closed both. So let's try running this. Now you can see that we are getting both closed and complete records. And one thing that you can optimize here, or one thing that you can fine tune here, instead of using R class couple of times, instead of using R class and then repeating this code again and again, you can optimize it a little bit by using in operator. So order status in, complete or closed. This will also get you the same output. You can see that output is exactly same, right? You can see that things are very simple, right? You just need some SQL concepts. That's it. You are just trying to create a data frame, register it, start using it as a SQL. So one assignment on filtering operation. The assignment is get all the orders placed on the first day of every month, right? If you can look here, right now we are getting the orders that are placed on the July 25th, right? But I want only the orders that are placed on the first day of every month. So that is the assignment. See if you can solve it. So you have to apply the filtering mechanism based on the order date column. See if you can solve that. And then let's see how to perform the join operation. So always remember, to perform the join operation, we have to have the common columns. Only then you can perform a join operation. But do you have any common columns? Let's find out. Yes, we do have order customer ID column from orders and customer ID column from customers. So these are the two columns using which we are going to use to perform the join operation. And one more flexibility that you get in Spark SQL is, if your query is lengthier, you can break down your code or break down your query into multiple lines, same as this, and keep your entire query in the triple quotes, something like this, right? So that even if your query is getting lengthier, it looks neat and clean, and it is readable, and it is maintainable. Hence, if your query is becoming lengthier, better to break it down into multiple lines and then keep everything in the triple quotes in this way. So now you can see that I'm saying select star from orders and select and join with customers. And look at the column names. I'm using order customer ID column from orders and customer ID column from customers. Let's run this. So we are getting the output, but how are we getting this? Look at the order customer ID column and look at the value 11,599. And also look at the customer ID column here. We can see the same value 11,599, right? So that is how you can basically figure out that because of this join operation based on these two columns, we are able to perform the join operation. And these first four columns are coming from orders, and the remaining columns are coming from customers. So that's how we have joined both orders and customers. Now one assignment on join operation. So get all the orders where there are no corresponding order items. To solve this assignment, you have to use the other data, which is nothing but order items data. So let's open this order items data. So you can see that we have got this data. We have got different fields: order item ID, order item product ID, order item quantity, order item subtotal, order item product price. All these fields. Coming back to the assignments, get all the orders where there are no corresponding order items. So basically, you have to create a data frame by using this order items data, and then register it, then perform the join operation, and then you will have to probably apply some filtering operation also to solve this assignment. So that is the hint. Now let's talk about grouping and aggregation mechanism. Suppose if you look at the data, if you look at the data here in orders, we have orders with multiple order status. We have orders with closed, pending payment, complete, and many more. We have processing also, right? Now let's say the problem statement is I need to figure out the count of the orders based on each order status. Count of the orders based on each order status. So that is where you have to use the grouping and aggregation mechanism. So the problem statement goes this way. Let me make a note of it. So the problem statement goes this way. So get the count of the orders based on each order status. Based on each order status. Something like this. Or let's say this could be something like get the count of the order status wise, something like this. So basically you have to look at your problem statement carefully. So if you look at your problem statement, you will get some hint. So if you can see here, whenever the interviewer is using terms such as each or every order status, then that's where you have to use group by on that specific column, and then perform the aggregate operation such as count. So that's what I'm trying to do here. I'm trying to group it based on order status, and then I'm trying to perform the aggregate operation such as count. And then I'm giving an alias saying orders count, so that we can get this output. Let's run this. So you can see that we are getting the output. We have two columns, order status on orders count. How to read this output? So there are 15,030 orders where the order status is pending payment. There are 22,819 orders where the order status is complete. There are 3,798 orders where the order status is on hold. So that's how you can actually figure out the output. But one important concept that you have to understand is the number of records that you will have after applying group by is actually equal to the unique values on the grouped column. So what I meant here is you can see that I'm trying to apply distinct on order status column. So these are all the distinct orders or unique orders that we have got. So the number of records that you will have after applying group by is actually equal to the number of distinct or unique values on that grouped column. Right? Have a look here. Look at the above output and look at the below output. Right? It's exactly the same thing. Right? So again, these are plain SQL concepts. Right? So after applying group by, number of records is nothing but number of distinct values on the grouped column. In this case, it is order status. So these are the unique order statuses that we have got. Hence, we are seeing only those in our final output. This is a plain SQL concept. One more SQL concept that I would like to highlight. If you look here, when you are using group by, that grouped column must be part of your select class, and remaining columns must be the aggregate operations such as count, min, max, sum, etc. But what will happen if I don't follow that? Take this example. I'm grouping it based on order status. I'm using the same in my select class. Along with that, I have an aggregate operation such as count on order status, but I have an extra column called as order ID. So this order ID is neither part of group by nor it is an aggregate operation. In that case, if you run it, it will fail. Let me show running it. Have a look here. Order ID is neither present in group by nor it is an aggregate operation, right? So this is a plain SQL concept once again. So when you use group by, always make sure that grouped column is part of your select class, and rest of the columns must be the aggregate operations such as count, min, max, sum, etc. And if you don't follow that, you will see this scenario. Order ID is neither present in group by nor it is an aggregate operation. In the previous example, we were using order status and it is part of select class. Apart from that, we are just left with only one column, and that is the aggregate operation such as count. Hence it was working fine. But if you don't follow that rule, you will see this issue. Okay, again, if you look at the problem statement, you will get some hints always, right? And there is no harm in asking for expected columns also in the output. So generally when I give the interviews, I definitely ask what are the expected columns in the output. So that way you're trying to extract as much information as possible from the interview itself directly, right? No harm in asking the questions in the interviews. Always look at the problem statement carefully, ask him to explain, and ask about the expected columns also, right? So probably they may say, okay, I'm looking for only these two columns in the output, let's say orders count. Then it becomes easy for you to solve the problem, right? Expected columns. So always read the problem statement carefully in the interviews. If you don't understand it, ask the interviewer to explain. Most of the interviewers will explain the problem statement. Also ask for the expected columns, and they'll also explain you the expected columns also. Based on that, it becomes easy for you to understand which approach you have to take it to solve a given problem. So 50% of your job is done in the interviews if you get as much information as possible from the interviewer itself. So that is the important tip. Okay. And once you get all this information, it becomes easy for you, right? You just have to look at the problem statement again. Whenever they use each or every, or whenever they use the word such as wise, customer wise, order wise, something like that, then you have to apply group by on that specific column, and aggregate operations such as count on that. You should be able to get the expected output, right? Okay, on the similar lines, there is one assignment that I would like to give. Get the number of orders placed by each customer, right? So again, look at the problem statement. I'm using a keyword such as each. So it's very clear that I have to apply group based on which column? Based on the order customer ID column. And then I wanted to apply the count operation on top of order ID column. I should be able to get the output. So the expected columns are customer ID and customer orders count. Customer ID and customer orders count. That is the number of orders placed by that specific customer. So that is the expected output for this particular assignment. See if you can solve that. Now let's talk about sorting operation. How to sort your data. And by the way, I was telling that if you're using a SQL query with multiple lines, you have to keep it in double quotes, right? You have to keep it in triple quotes, something like this. What will happen if I don't keep it in triple quotes? It will not work. Here, this query is going across multiple lines. I'm just still using single quotes. It won't work. If your query is crossing multiple lines, then you have to use put something like this. Only then it will work. I'm trying to use order by to sort my data. I'm sorting it based on order status column. And order status is a non-numerical column. It is a string based column. So it's going to sort the data in the alphabetical order, right? If you can scroll up, these are the list of all the possible order statuses. If you sort it alphabetically, cancel should be the first one, right? So that's how we are getting the output as it's showing all the cancel orders first, because I'm trying to sort it based on order status column. Now suppose I wanted to reverse it. I wanted to get the output in the reverse alphabetical order. Then you have to use DESC. DESC basically stands for descending order. Now if you look at the output again, if you can see here, out of all this, if you place it in alphabetical order, suspected fraud should come first in the reverse alphabetical order. Hence, I am seeing the same. You can see all these records are coming from suspected fraud. So these are non-numerical columns. Suppose if I want to sort it based on numerical columns such as order customer ID, I can again use order by and then customer ID. Let's run it. You can see that it is sorting in the sorting in the ascending order of order customer ID. You can see, look at the first column. You can see 1, 2, and then 3, and so on. Right? So that's how basically you can sort it in the ascending order. By default, it is ascending order. By default, it is ascending order. Suppose I want to sort it in the descending order of order customer ID. Then you can just use DSC. That will sort it in the descending order of order customer. You can see 12,435, 12,434, and so on. Right? You can sort it in the descending order of order customer ID. Now the question is, can I sort it based on multiple columns? Suppose I wanted to sort it based on the columns such as order customer ID and then order status. So ascending order of order customer ID and alphabetical order of order status. Is that possible? Yes, the answer is yes. So let's run this. You can see I'm using order by order customer ID. So by default, it is ascending order, that is increasing order. Hence, you can look at the order customer ID column. You can see 1, 2, 3, 4, and so on. So basically, it is sorting based on the ascending order of order customer ID. No doubt in that. Now let's look at the order status. So let me take these records. Now why am I taking only these records? Because if you look at the order customer ID is 2 for all these records. Now within that, if you look at order status column, we have complete, and then you have on hold, and then pending payment. So it is sorting based on the alphabetical order of order status column. Let's take these records. Now why am I taking these records? Because these records have got the same order customer ID. Order customer ID is 4. Now if you look at order status column, first it is showing closed, then complete, then pending payment. It is again following the alphabetical order. Now can I do descending order also? Yes, that is possible. You can see order by order customer ID, order status, and descending order. Right? So basically, I'm trying to sort it based on multiple columns and different order, ascending order, descending order, all that is possible. So now have a look here. First, let's see whether we are sorting the data based on ascending order or not. Order customer ID. Look at order customer ID. Then you can see that we have the look at the values in order customer ID column. You can see customer ID 1, order customer ID 2, 3, 4, and so on. So basically, this is fine. This is sorting the alphabetical. This is sorting based on the ascending order of order customer ID. What about order status? It should be in the descending order. That is reverse alphabetical order. Let's take these records. Why am I taking these records? Because all these records have got the same order customer ID 2. So if you look at order status column within those, you can see first pending payment is showing first, then on hold, then complete. Basically reverse alphabetical order. Then if I take these records have got the same customer ID, which is nothing but 4. And then look at the order status column. It's again sorting based on the descending order. You can see pending payment, complete, closed, etc. Again reverse alphabetical order. So that's how you can sort it based on the multiple columns, and then ascending order, descending order, all that is possible. Now one assignment on the same is try to sort it based on the um, customer zip code. Try to sort it based on the descending order of the customer zip code. Okay. So any questions till now, guys? Now you got a feel about how to work with Spark SQL. It's pretty easy, but again, in the project, in the interviews also, what I found is interviewers are more inclined towards using data frame APIs. Basically, whatever we learned till yesterday. But some interviewers are okay with Spark SQL code or data frame APIs, but some interviewers are specific about writing the code in data frame APIs only. But again, it depends on the interviewer, it depends on the project, but both are equally good. And with respect to performance point of view, both are same. Okay, now I'll ask you one interview question. So I told that you know why data frames are faster than RTDs. So I gave a simple one-word answers in the past, saying because data frames uses Catalyst optimizer, right? So now let's get into the details of it. What is Catalyst optimizer and how it works? Everything we are going to see now. So there is a simple diagram that I wanted to showcase. Understand this diagram is you have to read from left to right. So you can see that you can write the code in SQL approach. You can write the code in Spark SQL query, or you can write the code in data frame APIs. The first step is nothing but the unresolved logical plan. So let me make a note. So the first step is the unresolved logical plan. So the step one is unresolved unresolved logical plan. So what is unresolved logical plan? All the syntax all the syntax errors are checked. And if there is some problem in the syntax, it will throw parse exception. Let me show that. I'll show this practically now. So you can see that the spelling of from is FROM, right? So suppose if I make an intentional mistake here, instead of FROM, I'll make it as FRM, and I'll run this code, and you can see parse exception, right? Because the query is not correct syntactically, immediately we are seeing parse exception, right? So this is basically coming from unresolved logical plan. If there is any syntax problem, you will see parse exception, right? So let us put it back again. So I'll go back and fix it again. If you run it, it's working pretty much fine. Now let's say the syntax is fine, but the second step is logical plan where the column names and table names are checked. Let me make a note. Second one is logical plan, or it's also called as resolved logical plan, where all the column names, table names are checked in catalog. So if there is some problem, then you will see analysis exception. So you can see here, first step, let's say your query is correct as per the syntax, then it will go to the next step, logical plan or resolve logical plan. It's going to check your column names and table names in catalog. If it is not finding, then immediately it will throw analysis exception. Okay, so let me show this practical again. So, so if you observe carefully here, we have registered the orders data frame as orders. So I have to refer orders data frame orders underscore df as orders only. If I don't do that, it won't work out. Let's say instead of orders, I'll make it as orders underscore, let's say table. Let's say orders underscore table here. If you run it, it will fail. You will say analysis exception, table or view not found. Basically, and you can see unresolved relation. So basically, the problem is It's not finding that orders underscore table in catalog. Hence, you're seeing analysis exception, right? So you please avoid that mistake. So you should use the exact names. Otherwise, you will see analysis exception. Let me put it back again. So see here, we have a field called as customer F name, customer first name, right? Instead of customer F name, let me change it to customer first name. So is this query correct syntactically? Yes, it is correct. It will pass the unresolved logical plan stage. It will go to the next one. So then comes a logical plan. So where it's going to check the column names. You're seeing analysis exception. Cannot resolve customer first name. But good thing is it will give you the list of all the possible columns. You can pick up the correct one. You can see given input columns and you have the list of all the columns here. If you look here, we can see that this is the correct column that you should be using. Customer F name, right? It is checking in catalog. It's not finding any entry for customer F name, customer first name, and hence it is failing with an analysis exception. Let me put it back again. This time it should work, right? So the second step is resolve logical plan. Then comes the third step, optimize logical plan. So we have the third step called as optimized logical plan. So this is where the catalyst optimizer comes into the picture. The catalyst optimizer is nothing but a rule based optimization engine. So basically whatever Spark code that you write, Spark will automatically try to fine tune it. So it will try to optimize your code so that your code run faster. So that's where Catalyst Optimizer comes into the picture. It maintains some set of optimization rules in the background. It will apply all those rules on the Spark code that you have written, right? So that's where Catalyst Optimizer comes into the picture. So the next stage is nothing but physical planning, where multiple physical plans are generated, right? So let me give an example here. Let's say that you wanted to go to your office from your home. Now, to go to your office from your home, there could be multiple ways, right? So some people take the fastest route, some people take the quietest route, some people take the route where the road is nice, right? Some people doesn't want it to take isolated route, all that. So depends on your preference. People will take appropriate route. But again, the point is clear. If you wanted to go to your office from your home, there could be multiple routes, right? You can think of these multiple physical plans are the same. Then here you're going to act as a cost model, because based on your priority, you're going to pick up the best route. So similarly, we have the cost model here. Out of multiple physical plans, it's going to select the best physical plan so that the code gets run faster. So after this optimized logical plan, we have the physical planning. Physical planning where multiple physical plans are generated, right? Now out of the multiple physical plans, so someone had to select the best physical plan. That's where cost based model comes into the picture, or cost model comes into the picture. So then the next stage is cost model. So cost model will select the best physical plan. So what is the meaning of best here? The meaning of best is nothing but making sure your code, your Spark code runs faster. So cost model will automatically select the best physical plan, which will basically run your code faster. Then comes the next phase is code generation. Code generation. So what will happen in the code generation? Optimized RDD code will be generated, which will run on the cluster. So basically remember guys, whether you write the code in RDDs whether you write the code in data frames or not, ultimately the code has to be converted to RDD code. But again, this is not the plain simple RDD code, it's optimized RDD code. It is optimized because it has to run faster and it has to go through all these phases. And finally, this is the last step. So even though you're writing the code in data frames, internally the code finally gets converted to optimized RDD code, and that is generated on the fly. This is important, guys. So interviewer may ask you about Catalyst Optimizer, or they may ask you what are the different phases that you have when you run your code. Right? You have to understand and explain all this. Very very important interview question also. Or they may explain about, or they may talk about why data frames are faster than RDDs. Then you'll talk about Catalyst Optimizer. Then they may ask you to explain more. This is what you have to explain, right? Any questions in this? Any specific questions in this? Okay, I think pretty much this is what I want to cover today. Again, as I told, Spark SQL is not of great importance, to be frank, because but performance-wise there is no doubt both are same. Spark SQL or data frame, performance-wise you'll get the same performance. But one advantage with respect to Spark SQL is if you wanted to implement some features quickly, then you can go with Spark SQL. But otherwise, in the interviews in the project, most of the people prefer to go with data frame APIs only. And some intros are very specific. Even if you write the code in Spark SQL, they want you to write the code. Okay, guys, any questions so far? So tomorrow we'll talk about Spark structured streaming. So how to deal with the streaming data. So that will be a very interesting session. So if there are no questions today, let's catch up tomorrow. I will share this notebook with you today. Right? I can say file, download as HTML, and I'll share this HTML file with you. So keep this as reference and start practicing it. Okay, and so try to solve these assignments also, because these are all real-time interview questions which are picked up directly from the interviews. So before closing today's session, any questions? Okay, tomorrow we will see how to practice Spark structured streaming on IDE such as PyCharm. That will be even more interesting. Okay, let's catch up tomorrow then. See you. Bye.